Hello guys, how are you doing? Let me trust you're doing good. Welcome once again to this video. Today we have this motherboard to fix. The customer sent it to us without the casing, without the screen, without nothing. It's just sent the motherboard and the power port here. You can see. So it came with the envelope. Here's the envelope. I don't need to show you, but anyway, I'm showing you anyway. Okay, that's not the business for today. My main issue is to fix this. Can we fix it? Yes, the customer said he took it to the technician and the technician tried to repair. Then later on, the technician said this one is not working or it is beyond repair. That's when the customer decided to bring it to us. I don't know whether we will have a chance to fix this here, but anyway, we are going to try it. So the first thing we need to do is to do the physical inspection. As always, guys, as always. Every now you receive any laptop or any motherboard, the first thing you need to do is the physical inspection of the motherboard. So here with me, I have HP. This is HP NV, HP NV 15, I believe so. And as always, the physical inspection, I can see this side, I can see everything. Then here I can see this EC chip. This is an EC chip, and I can see some signs of soldering paste here. So somebody have reflowed this IC. So let me hope nothing happened to it. So let me hope it was just reflow, and then everything is still okay. Then after that, we do have what again? We do have MOSFET here, which has been somehow replaced, and it shows that there's a sign that the MOSFET which was here already, which has blown. You can see the broken layers here. They are burnt layers. So anyway, so I can see here we shall work on here. I don't know what happened there. Then again here there was some components which has been removed already. So I believe I know what happened to this motherboard because this is MOSFET. I believe this is MOSFET one. And this is the MOSFET one. MOSFET one normally got blown up when we have the short in the main power line. When you have a short in the main power line, the system tries to return back. That is the backflow of power. The system tries to protect itself by returning back the voltage into the origin. And this MOSFET one is what we call block MOSFET. So MOSFET one is block MOSFET. So when you plug in power, when you plug in an adapter, when you supply power to the motherboard, and then that power gets returned back. That power gets returned back. It is blocked by this MOSFET. When this MOSFET blocks that voltage coming back, and already you still have a voltage you are forcing it through the coming from the adapter. Those voltages accumulate here at MOSFET one. This MOSFET tries to block the power coming back, at the same time try to direct the voltage into the motherboard. Then you will have accumulation of power at this MOSFET until this MOSFET will automatically do what? Get blown up because it will give up, right? Yes. So let's confirm whether that is indeed the MOSFET one. So here is the power port. You can see the power port here. Then I have the power diode here. Then I can't see the line connecting these ports into these MOSFETs. However, let's check at the back. Maybe we'll have a hint there. As you can see, here at the back, I can see we have a track here. This is a track which is going this way. It's going this way. I don't know where it is going. We just follow it. The track is going this way. Let me hope we are following together until it disappears here. Yes, it disappeared here. So once the line disappeared, it means it goes to the back. It goes to the other side, and exactly that other side is where we have MOSFET 1. So this is probably MOSFET 1, MOSFET 2, and then we have a current sense resistor. Then apart from this current sense resistor, we also have a MOSFET which is bringing voltage from the battery because we have the battery here. Again, the battery has its own line which is coming this way. And that voltage coming from the battery comes through this MOSFET, and then it goes directly to this current sense resistor. Then from here, now the voltage is sent into the motherboard. So from this current sense resistor, this is where we will have the main power lane. So from here we'll have the main power lane, and that main power lane goes into the entire motherboard. We'll have now step down voltages within the motherboard. Now, So since we've identified the main power line, MOSFET 1, MOSFET 2, we've seen them and we've seen what happened to the MOSFET 1. Now, what we need to do now is to test the main power line, whether we still have a short there. Because I believe the reason why this MOSFET got blown up, because we had a short in the main power line. So first of all, how do you test for the short in the main power line? By using a digital multimeter. So as always, make your digital multimeter be your friend. Yes, this digital multimeter should be your best friend. As always, turn on your digital multimeter, put it in the pipping mode, that is the homes mode, and then we'll have the pipping mode there. You can see you select the pipping mode. Now we have the pipping mode. How do you test the main power line whether it is shorted? Put your meter in pipping mode and then have one probe into the ground. Then put another probe into the main power line. In case I have flow resistance or I have the pipping, the main power line that is shorting to ground, it means the main power line is shorted to ground. If there is no pipping or I have unlimited or infinite resistance, that means the main power line is okay and I am safe to plug in what? I am safe to plug in the power adapter. So as always, one probe to the ground, then another probe to this current sense resistor, because this current sense resistor is the one which is connecting all the main power line. As always, you can see there is no pipping. So what does that mean? I do not have the short in the main power line. Can you see? Yes. So it means the main power line is good and it is safe to plug in the power. Right? Yes. So from there, we are going to plug in the power supply. Then I'm going to read how much this motherboard is taking or what the behavior of this motherboard. So I can't see my top plug for the blueprint because this motherboard uses the blueprint. I have the power supply here, but this one is the big pin. Can you see? This is the big pin. So I guess I have to look for the blue pin, which I have no idea where is it. Did you see it somewhere? Here, I got it. So this is the blue pin. I need to use that top plug, this top plug. So this is for the blue pin. Now I have the blue pin for the power supply. So don't worry about my power supply is still off. So let me just put it on and then voltage 19.7, then current let me set to be 5 amperes. Now let's see what happens. I am going to read you the values or the measurements of what's happening. Now my voltages is at 19.7, that the amperes is reading 000 and I haven't plugged in here. So let's plug in and see what is happening. When I plug in, still 00. What does that mean? It means there is no power going into the motherboard. It means there is no power going to the motherboard. Let us check. So I have the voltage there, voltage mode. I'm going to use the voltage mode. Now, once I am in the voltage mode, my black probe is always to the ground. My black probe to the ground. Then my HATA probe. I am using my HATA probe to test the main power line, whether I test the voltage. As you can see, main power line, it is zero voltage, 0.013. Good. What about the input of this MOSFET? The input of this MOSFET serving 19.68. What about the output? Zero. So it means there is no voltage going past here. I don't know whether you're getting this or I'm just explaining to myself. Can you see this MOSFET which was repaired here? This guy which soldered in another MOSFET here. He soldered a MOSFET which is taking voltage in. That's 19.68. This MOSFET should switch the voltage into this other side. It should switch the voltage into this other side, but in our case, no voltage. So we have voltage this side, and we do not have this side. In a simple term, what shall we do? Since I know the voltage which is entering here should go to this other side, I can even try to force that voltage. I want to see whether if I force the power to go into the motherboard, can this motherboard powers on, or can this motherboard get shorted? So let's try it. See, and how do you do that? We twist, with a tweezer. Yeah, yes, we jump that voltage. So this is the input. Then we should have the output. Then you see some sparks, and the motherboard is taking 26 milliamps, that is 0.026, which is very good. That tells me my motherboard is not shorted. When I try to switch the power button, it is just igniting 75, and then it goes off. Somehow, I think, and then there's a flicking of light. Now, what I have to do now, let me chop, because I want to see the constant flow current there. Switching it, it's just a temporary. It's just that I'm just making sure the voltage is going to the other side and it is not constant. So what I have to do, let me solder in power to come from the, or I can even remove that. Let me remove that MOSFET here. Let me remove this switch, then I can even replace with another one. But first of all, we need to make sure this motherboard is powering on. We need to make sure this motherboard is powering on. Oh, I'm sorry, the power is still plugged in. Huh? So let me have this MOSFET out first. Now the MOSFET is out. The MOSFET is out. Once the MOSFET is out, I said we are going to loop there. We are going to jump the voltage there. And how do we do that? The way to do that is to solder in what is it? We've bridged. Huh? Yes, it was all about bridging the power, the crossover. Once you can you see the bridge? This is my bridge. I just solder in a solder, connecting this side to the other side. Now, I should not have any problem having the voltage crossing over. Now, my next thing is to do what? Is to plug in. My next thing is to plug in the power here. So let's plug in and see what's happening. 15 milliamps. And then I have an orange light there. Taking 15 milliamps, then I have orange lights. Let's try and switch it and see what happens when we switch. So this is the switch. What's wrong? Can you see? And it's making a certain noise. And where is that not coming from? There's a certain noise coming from somewhere. What? I hear some noise. Huh? There's something wrong somewhere. The laptop tries to power on, but I think the noise is coming from the CPU. Something is clicking. Can you hear? I do not understand what the hell is that, huh? But it's coming from the CPU. Now, what shall we do? Let's keep on. What is this? What chip is this? Because this one also has been, and there's a problem here. So let's reflow this. All of these chips which already has been reflowed, because I think we still have some issues with them, and I have no idea why were they cutting reflowed? Huh? because even me myself actually I do not understand what was happening here. This laptop seems to have been having a problem to do with the spillage. And again, guys, working with these motherboards, which has undergone some trial, it is sometimes not easy, and sometimes we do not waste our time working with them, because this one somebody has already tried a lot of things. Until me personally, I do not understand where was the initial issue. Yes, with this one, at least I understood there was something to do with the MOSFET one getting blown up. That is automatically because the motherboard was having a short in the main power lane. Now we do not have any short in the main power lane, but still the laptop is not powering on. And again, this chip getting reflowed. This chip is responsible for switching, and somebody have reflowed. And now I am topping up the reflow. That one is okay. I do not see any missing component. Then again, there's another chip here which is badly corroded. Let's reflow it again. Instead of cleaning it, we can just reflow it because the problem is to do with the pins for these chips. However, I know this one cannot affect the powering on because I believe this is the chip for the sound. This is the audio chip because I can see at the top it is written ALC. However, if it is the bar, if it is the no, this is not the ALC. This is something else. This is something else. First of all, let's focus on making the laptop to power on. Then understanding these chips is something for later hours. The chip is reflowed. The chip is reflowed. Now, do we still have something else which need reflow? I do not think so. Okay, since I don't understand what is wrong with this CPU, but there's something I am a bit aware about these AMD CPUs. Normally, their joints get cold. Yes, most of the time you find that they get cracked bolts, solder bolts below them. You know, these main chipsets are soldered by what's called a BGA. That's a ball grid arrays. So those solder bolts normally get cracked and they detach themselves from the chipset to the motherboard. And I do not think that is the. I don't know whether that is the reason why I'm getting some weird sound from the processor. Maybe, maybe not. But anyway, now let's try again. Let's try again and see whether we'll get the weird sound again. Once we get the weird sound, we shall try and reflow this chip. However, I do not think it will help, but we just have to try it anyway because after all, there is nothing you can do about it. Still orange light. Still orange light there. Can you see? Yes. Here we have an orange LED. Then, since I have an orange LED, let's again try and switch it on. And then now, bim, 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 the laptop is coming on. Yes, 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 yes. The laptop is powered on. Actually, did you see the light? Okay, I didn't want to stay too long here because this is an AMD processor and it doesn't have what? It doesn't have the CPU. So what I'm going to do, I can try to use this. I'm going to use this piece of tissue. Then Uh, it's a cool one, eh? I'm going to use the. I don't had some thermopad somewhere. Let me look for the thermopad. I think we have thermopad somewhere. We can use it to cool down the CPU. Then we are going to try it out. There's nothing here. I thought I had it in my box somewhere here. I don't know where it went, but I believe I have it somewhere. I know some of you eager to see what's the thermopad. And yes, I got it. This one. You're going to use this thermopad, then you're going to use it at least to try and cool down the CPU. I'm very happy at least this motherboard get powered on. I didn't believe it was going to wake up because it does a lot of repair attempt, a lot of problems. I looped the power from MOSFET one. Once I have the laptop coming on, once I have the laptop powering on and having the display, I will uh, I will now work on that MOSFET. Now my main focus is to make sure the laptop is powering on. Yes, and to do that, still let's plug in the power. Now we are going to use, since the customer did not send us the screen for this laptop, so I am going to use this keyboard to test for the display. And how do you display of a laptop of a motherboard with what? With only keyboard. When you have a display, we shall see the keyboard here having some lights. There's a cap lock or a number lock light here. So as always, we use the RAM. Yes, make sure you plug in the RAM. So this is my RAM. We insert the RAM in. Once I have the RAM, we plug in the power, taking 15 milliamps, 22 milliamps. Now, for the AMD processors, you must switch. You must switch these motherboards. Let me just put it this way so that you can see. Let me hold the thermopad. It's getting not there. It's falling down. Now, I want you to see the switch. Before it was blinking, not steadily. Maybe because that he was having an issue. You see, the LED is constant and the laptop is at 800 milliamps, 1.1. That's a 1 ampere. The CPU is getting mad hot. Now let's wait and see whether it will display. Since this motherboard was not having the battery, the CMOS, so I believe it will restart for some time before it actually uh, get the display. 143 amperes, smart hot, very hot. As we wait, we shall see the light. Yeah, when we have the display, we shall see the light there. Hey, it's really, really hot. Yeah, the CPU is getting hot. I don't know how to help it. It's not helping. So we wait for the display. 700 milliamps, that's not bad. And I do not understand why am I not getting the display. No, 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 guys. You're not telling me I haven't plugged in the USB. Huh? You're just there watching. And I haven't plugged in the USB for the keyboard. And still, even if I have plugged in, I can't see the light still. Hmm? Or can you see anything? Me, I can't see anything there. Normally, these high-end laptops takes some time before it shows the display. Now there's no way I can indeed verify the display because if the ports are not good, if the ports are damaged or are not working, uh, my testing cannot work. We always need we always need what? No, I can't confirm. I'll need the screen. But anyway, let's just because the laptop is powered on, I can see it is powered on. Maybe the ports are not working because I expected to see the caps lock lights here to show that the laptop is having the display. But now there's nothing. However, this orange light is alarming. It should have at least be white. But anyway, I'll give you an update once I have the screen. I'll send it to customer the way this because the customer decided to send the motherboard alone to me. So who am I? I'm just going to make sure that the motherboard is powering on. That's the story to do with the display. There's no way I can confirm that. Now, since I have the laptop on, so I do not have any problem with the mainboard now. But my main business right now is to deal with this. Is to deal with this like this MOSFET one. Yes, that's my main problem right now. Is to deal with this MOSFET one. Since this layer get blown up, the layers get blown up, and these layers, we have the drain, we have the source, and then we have what? The gate. I'll have to make sure that all those three parts are connecting to the MOSFET. So first of all, I have to find the MOSFET which should fit there. And where do I get that? My guys, where do we get that MOSFET? First of all, which power IC are we dealing with? We need to know which power IC we are dealing with first, so that we can know which MOSFET we are going to replace there. The power IC I'm dealing with is BQ737. Yes, BQ737. I do not know whether I have a MOSFET which should match that driver. I have a box here containing my own things. Yes, these are my witchcraft. Yes, these are my witchcraft for witchcrafting the motherboards. So first I need to let me confirm which MOSFETs are this so that I can know which MOSFET I can replace there. Because these motherboards, even though these MOSFETs or these switches, they are power switches. Yes, the MOSFETs are power switches. It switches power from one point to the other. So I cannot just replace a MOSFET with a MOSFET. First, I need to know which MOSFETs we are dealing with. This one is 7403. Where? I do not think I have this. I do not think I have this kind of MOSFET. But anyway, let me try. Let me try. At least I know these MOSFETs you are dealing with are these small ones. This one is 4004. We have different types of MOSFETs depending on their respective drivers. 74004. Can we try this? Okay, let me just put that one there as standby. Or this are the, oh, what am I seeing? 7403. Those are the MOSFETs. 7403. 300. My guys, are we lucky today? But what I'm just happy about is that the motherboard is powered on. Yes, I am 99.9%. I am 99.9% that this motherboard will work. Yes, since the problem was to do with power, 7380. The other one, 7303. 7380, maybe in that one it work again. We shall have some few to try. You want to see what I am selecting? You are eager to see what am I dealing with. This is my small box for my personal stuff, for my work. I believe the reason why the MOSFET which was soldered there by my other guy, it wasn't switching because it was not the same as what was needed there. It was not the same as what was needed there. If you put a wrong MOSFET, it will not switch the voltage. Even if it switches the voltage, you will find that it might not charge the battery. Because those MOSFETs again are responsible for charging. They are responsible for charging. And if they are not coordinating the voltage correctly, automatically they will not behave the way it is needed, the way they are needed to behave. You will find that they may not be able to do the judging. No, my guys, I can't get what I am looking for, but we are going to try that 7803. First, let me have this one out. Now, my guys, my MOSFET is giving me some funny headache. It's misbehaving, man. Now, let's have a MOSFET there. We are not going to try other things. Which was our friend? Was it this one? Again, we need to pay attention to the type of the MOSFET we are going to put there. These are the pigeon MOSFETs. Uh-huh. Yeah, that MOSFET in. Now, since I have that in, I need to have it connected to the gate. I need to have it connected to the gate. You put in the solder paste because this gate is like it's what coordinates the switching. It's what coordinates the switching of the MOSFET. And if there is no gate signal, these are the signal coming from the going into the charging IC and coming from the charging IC. If we do not have the signal coming from the charging IC, there is no way you will expect the switching to occur. Why? Because we need the coordination, we need the communication. We need instructions. These MOSFETs need instructions from the judging ICs for them to operate well. Now I have the MOSFET soldered. Now you have to trim this pin or the gate. Do you have any miracle? Hmm? Do we? Do we or do we not? It seems like it is soldered. No, 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 my guys. There's a problem because I can see the source is connecting to the drain, which is not good. Because now, once we have that, it seems like we just breach it. Uh-huh. This is Toji repair. Very funny. Very funny though. Let's see the miracle. If it really works. Or if it will. Wow. And actually it worked. Can you see? Yes, it worked. Now, can we see whether it will switch on? And then boom, it switched on. We can't test for the display. The laptop is powering on. What else do you need me to do? Let us measure the gates. Let us measure the gates whether they are giving out the voltage which are needed. The gate for MOSFET 1 or 2, in MOSFET 1, at least we should have 6 voltage. If not 6, we expect to have 25 for the charging and for the charging ID. The 6 voltage is charging ID, 25 is for the charging. Then MOSFET 2, the gate for MOSFET 2, we must have 25. We must have what? 25. Let's see. Let's see whether we have those voltages. So black broke to the ground, then red broke to the gate. The gate 6. What about the other one? Here it's the dot. So meaning the gate is this other side. So we expect to have 25 voltage here. And then we do not have. Now we do not have 25. Why? Because we have still what? In fact, we have nothing. Eh? No, that's the main power. That's 19. We say the gate we should have uh, 25, and we do have 0. Why? Why that? Hmm? Does it mean that MOSFET 2 again got shorted? Huh? Because now I do not have another MOSFET to put there. Hmm? To do so, we went heaven and earth to get the MOSFET 1. And again, we were lucky, at least what we put there, it worked. We were looking for 70. What was the number? But we got a different number. Let me just put some paste there. It's like preparing chapati. But let me make this solder at least to be presentable enough. Now I want again. Let's again test that. Or we are thinking that we solved the issue, yet we created a short. I expect the source not to connect to the drain. So here I have the source and then drain is here, and very lucky it's not connecting. So I believe everything is okay with this motherboard, despite the fact that this one is not giving us 25 voltage for the gate. Everything is good. So with this MOSFET, I am going to locate another MOSFET there. Then we can substitute that. Can we try another 7803? I don't know whether we're gonna get it or not, but bottom line, we need another MOSFET for that site. What is this? Where did it go? It flew away. This one is the 7404. Can it work? Can it work? First of all, let us test it whether it is good or shorted before we solder in there. This one is perfectly good. Perfectly good. We are going to use it. Let's use it and see whether we have any miracle there. Let's desolder this. This one is out. Let us solder in this. And see whether we have a different results. Huh? We have new fresh MOSFET there. We're going to see whether we have something different about it. Let's see this one which you just removed. This one also seems to be good. Now, what you're going to do, let's plug in and see what is powering on. And the motherfucker is not working. This one is not working. Yes, it's not taking any power. 8000. The reason why it's not taking power because this MOSFET is not coordinating with the other one. That's why they are not compatible. So let's just put back the original. Let's just put back the original. When the customer said at the back with the issue of not charging, that is a warranty like that. I know it's not right because we do not have the battery. In fact, we do not have the battery. In fact, we have nothing for this motherboard. We have nothing. We just have the motherboard and the power port. So we just have to fix the issue to do with power to make sure the motherboard is taking power and is powering on. Then other things we can't test. We can't test 100%. So when I get a machine for a customer, whereby the customer sent in few things, that's not my problem because the customer knew this motherboard was not powering on. So I need to repair it. Once it powers on, I need to confirm again it is charging. Now I do not have the battery. I do not have the screen. Generally, it's like I have nothing. It's like I do not have I have so many things which are missing, which I also need for this laptop. But instead, I just received the power port and the motherboard. That is it. So what am I supposed to do? To deal with whatever I have. I need to deal with whatever I received. Huh? So again, plug in, and the laptop is getting an orange light there. The other one wasn't. Then can it switch on? And the laptop is powering on. That is it. 900 milliamps. That is good for this motherboard. This motherboard is a heavy motherboard. Also, it does a AMD processor. This is AMD Ryzen. Probably this is Ryzen 7. This is a very heavy one. I had motherboard. Very nice one. So, guys, thank you so much. I am really appreciating your patience and your presence as a family. Thank you so much. Please, guys, still if you haven't subscribed to our channel, I'm still requesting you, my people, please subscribe and share with your friends who are interested in learning about laptop repairs. We do laptop repairs. In case you have an issue with your laptop or you know somebody who is having a problem with this or that laptop, you can just connect them with us so that we can help them. You can send your laptop to us, we repair it and we parcel back, or you can bring it yourself. Again, in case you're interested in learning about laptop repairs, you can come over. We do teach both online and outside. If you want a physical module, you are highly welcome. You just contact me so that we can discuss 1212 the logistics, which whatever it is needed, and anything you like to inquire about the learning how to do the laptop repairs. So guys, thank you so much. Please do not forget to subscribe and share with your friends. Thank you so much. See you in the next video. Bye bye.